Hello my dear friends, welcome to IMS Gate Academy. I hope you people are doing good and you people are preparing for Gate 25 for doing whatever you want to do, right? So my dear friends, you should start preparing for Gate seriously from now onwards. Yes, you might feel like you have a lot of time on hand for the examination, but days will pass by and you will not even realize it. So it's high time you start working on your fundamentals. No time is sufficient for the examination. And to help you out, we have started with the fundamental series, that is a foundation series rather, and I am dealing with the strength of materials. Similarly, many the other faculties will be taking other subjects. So today is the 10th lecture on this foundation series, and as I promised, I have covered most of the, I can say, the fundamental topics as far as your SOM is concerned. Yesterday we discussed with bending, and today's topic will be torsion. Today we will be discussing torsion equation, torsion chapter as a whole, how the torsion is coming into picture, what is the effect of torsion. All these fundamental series we will be discussing in this 1 hour of session, right? So my dear friends, let's get started. So yes, today is the fun, and let me tell you that this is not only helpful for mechanical but for civil as well, right? So my dear friends, you might consider joining the Telegram group, where you will be getting the schedules of free YouTube lectures, you will be getting the lecture PDFs, you will be getting the important updates related to seminar, webinar, you will be getting PSU and other government job notifications, some important topics will be there, so you will be getting that, and daily quiz and much more, right? And my dear friends, if you wish to take the GATE online program of 25-26, so the features are very important. So what features you will be getting? You will be getting 800 plus hours of live classes, theory book, exercise book, 4,000 questions will be there. This is the game changer. Yes, this you will be getting, that to 2 big books you will be getting, and if you practice that, we can say that you are at least 60% ready for the examination if you do this rigorously. 12 personalized one-to-one sessions will be there. Again, during your course of preparation, if at any time you feel that you need help, you need to talk with the mentors, you can book my plan sessions. And finally, my dear friends, tests will be there. Tests will be provided to you, and as much as 130 plus online tests will be there, right? So my dear friends, today's topic of discussion is torsion. What is a torsion, my dear friends? Torsion is referred as twisting a member. We twist something. Twist, I hope you are able to get. If I twist, and basically I am talking about shaft, circular shaft I have written. Torsion of a circular shaft. Now you know that circular shafts are so important in any machinery. Basically the automobiles, it's an integral part, so shaft is there, or any heavy machinery you will be finding everywhere, the axles, the shafts, it's a circular member, and it is subjected to torsional moment. So what is the effect of that torsional moment? And if we analyze this, it will be helping us to in the design of the shaft. Based on this only we'll be able to design a shaft. So that is why the study of torsion is needed. So basically we have to deal with the circular shafts. Circular is a symmetrical body, the cross sections are same throughout, but unsymmetrical study we can also do, but as of now the equation that you will be developing, it will be for circular shaft only. So what is a torque? Torque is a moment which causes twisting of a member along its longitudinal axis. Yesterday I have told you that what is a longitudinal axis, I have discussed with you. So, again I'll be telling you, but the main thing is that you need to understand that, okay, twisting is happening, twisting, this effect is called as twisting. Some assumptions are there which are, which we use throughout our strength of materials concept. What is that assumptions? That material is homogeneous and isotropic. Homogeneous means density equal to constant, density is same throughout. Isotropic, material properties are same in all the directions. This and throughout in SOM we use this. Loading is within elastic limit. My dear friends, you have to use the Hooke's law, and Hooke's law is valid within the elastic limit only. So you will be understanding that, okay, this is applicable throughout, so no issues with that. And weight of the member is neglected. Yes, remember when I was discussing the internal loadings, so there also we discussed that, okay, weight is neglected, and here also I have written the same, weight of the member is neglected. So myself, dear friends, we are basically talking about this picture. If see, I've used many images for explaining the concept, and if those images are clear, so you will be having very less problem as far as the concepts are concerned. You will be understanding. So see what I am trying to show you, that here are two types of line. One is the circular line, throughout the shaft, and one is the horizontal line drawn on this, and this is the picture before deformation. And if you apply torque, as in over here I have applied torque, so you can see that longitudinal lines have become twisted, and circular lines remain circular. That means from comparing these two images, you can clearly say that some deformation has happened. And due to that deformation leads to change in shape or size. Change in shape or size means strain is there. Strain is there means stress is there. Stress is there, so force developed, torque developed, all those things are there. So these things you have to see, that radial lines are remaining straight due to after deformation, longitudinal lines become twisting. The objective of this image is to show you that, okay, some changes are being taking place in the shaft. Okay. And one important observation is there. What is the observation? Observation is that if the angle of twist is very small, then the length of the shaft and its radius remains unchanged. The length of the shaft and the radius does not change. Okay. Now coming into some more detailed picture, if you ask me, then I hope that you are able to see that I have taken a plane across a length, I have taken a plane, and if I apply torque in this manner, then you can see that the plane is changing. The plane is getting twisted. I hope you are able to see this result, that how the deformation is changing. How the deformation has happened. First is an undeformed plane, and then if it gets twisted, then some displacement is taking place. This displacement I hope you are able to find out. This displacement you are able to find out. Right. And one more thing, definitely one of the ends is fixed, so that when you apply the torque at the other end, so a reverse torque gets generated on the other end. So definitely it is fixed, then only you will be able to create some deformation, right? So as of now in this image I can say that, okay, this image is more or less fixed. This image is more or less fixed. This image more or less is fixed. Okay. And one more thing, my dear friends, I hope you can feel this, that at the free end the angle of twist will be more. I hope you are able to feel this, that see, whatever torque I have applied at the end, the angle of twist is there. That means some angle change is there, some twisting is taking place, and that thing is negligible at the fixed end as with respect to the free end. At the free end the angle of twist is more as compared to, that means see, I can say one thing, that angle of twist is depending on x. Yes, very important observation, my dear friends, that from this concept, from this figure, that means at the free end the angle of twist is 0. Then you move along, it will start increase, and finally at the free end the angle of twist will be, you know, maximum. So I hope you are able to feel this, that angle of twist, that is, let's say, you know what, phi, here it is, phi is proportional to x. Therefore, it is maximum. It is maximum at the free end. Maximum at the free end. Okay. So tell me one thing, if it is maximum at the free end, so I don't know why I am writing always theta, so let it be theta only. Let it be theta. Just a minute. Let it be theta itself. Let it be theta. Okay. So at the free end, theta is nothing but okay. Theta is nothing but theta max. Okay. So if theta is equal to theta max, so theta max by L, can I say that it is constant? Because length is constant, at the free end theta will be maximum, so theta max by L is a constant thing. Okay. Now my dear friends, see, I hope you are able to guess that, okay, strain will be there, that means deformation will be there. If deformation is there, that means strain is definitely there. Strain is definitely there. And if now I'll try to explain you that how shear strain is there. Shear strain is there, but how shear strain is there, this I'll try to explain you. So now imagine, see, whenever you have to study or analyze something, you take a segment, you take a small segment and then you do some study over there, and based on that you will be deriving some results. So similarly, one segment has been taken. 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 One segment has been taken over here. One segment has been taken over here. One segment has been taken, and I don't know, but if you are able to see this, that okay, on that segment one element I have picked up. One element I have picked up over here, and that element I am trying to study. See, all is at a distance x, all is at a distance x, and then I am trying to study this element. This element, when it is enlarged, this, the figure becomes in this way. Where was the element? The element was present over here. That okay, on this part, a small segment, out of that I picked up one, you can say one block, one small block I have picked up. And when I picked up that small block, it has taken this shape. It has taken this shape. So my dear friends, see one thing, when you are twisting across the circumference, if I say, then definitely earlier this was the case. This is an undeformed plane, and after that what has happened? After that it has twisted by some angle. It has got twisted by some angle. What is the angle? Angle of twist. An angle of twist is present over here. You can clearly see. This is the radius. This is the center. Center says this distance is across the radius we are studying. Across the radius we are trying to study. So angle of twist is there. Okay. Now my dear friends, what is shear strain? Shear strain is, I'll try to explain you that earlier this was the, the plane was something like this. Earlier the plane was something like this. I hope you are able to see AB, this dashed line. the dashed line, and after you twisted it has become AD. After you twisted it has become AD, this line. I hope you are able to see two red lines. I hope you are able to see the two red lines. So earlier it was this. So some change. So why I am showing you? Because the now AB and AC angle was what? AB and AC, the planes are 90 degree to each other. So earlier it was 90 degree. That is a pi by 2. And then it has twisted by some angle, and now the angle is theta dash. Let's say now the angle is theta dash within this. So what is the shear strain? Shear strain is pi by 2 was the earlier minus theta dash, and that is the shear strain. And I hope you are able to clearly see from this figure that okay, this is the theta dash. So question can come in this way also. They can give you this image and they will be giving you some angles, and then he will ask you that okay, find the shear strain, and from that you will be able to find out. Okay. So what is this figure actually? This figure is, this is a segment taken from distances are calculated with respect to radius, and this is the changes, which is, that means he is trying to show you that okay, shear strain is being happening on the plane. Shear strain is being, shear strain is taking place. Shear strain is taking place. I hope you are able to understand this figure. Now as of now, don't focus on this relation. As of now, don't focus on this relation. I will be explaining you that how this relation is coming. So angle of twist is what? Angle of twist is theta. Angle of twist is theta. Shear strain is denoted by this gamma. Shear strain is being denoted by this gamma. Shear strain is being denoted by this gamma. Now my dear friends, see one thing. I'll try to draw one image, and hopefully you should be able to understand. Will this do? No, this is not working. Okay. Okay. So we are talking across the shaft. We are talking across the shaft. We are talking across the shaft. We are talking across this shaft. So basically this is the longitudinal axis of the shaft that I am showing. This is the longitudinal axis. And from here, let's say you are trying to study this plane, and if you apply some torque over here, the torsion if you provide, so it has got twisted by some angle. It has got twisted by some angle. Let's say this angle is theta, and this theta is your angle of twist. This theta is your angle of twist. Now I hope you are able to see this thing. I hope the image is clear to you. This is the angle of twist theta, and this is the shear strain, my dear friend. The thing that I was trying to show you, that this is the shear strain. That means if I draw in an enlarged manner, only this part if I show you, so this is the angle of twist. This is the angle of twist. If you apply torque in this way, this is the angle of twist. And this is the shear strain. This is the shear strain. I hope that you are able to understand this concept. And this is the distance from the radius, this is the distance from the radius. I have just cut or intersected one segment over here and I have tried to show you. What is theta? Theta is the angle of twist. And what is gamma? Gamma is your shear strain. Gamma is your shear strain. So two things, if this image is clear, then only you will be able to proceed further. I hope I am able to show you. This is across the radius, it is constant. Theta across the radius is constant. Gamma across the length is constant. Gamma, that means the shear strain, is not changing with length. It is changing with radius. It is changing with radius. How it is changing, I will show you. How it is changing, I will show you. But as of now, you just have to visualize that, okay, what is gamma? Gamma is the shear strain. What is theta? Theta is that means, see my dear friends, I have to connect gamma and theta, and I have to connect gamma and theta. How can I connect? I can connect with the help of this curve that you can say, this curve you can say, this curve. Let's say I am naming this curve as AB. This is the connecting link. This is the connecting link. See, generally I am showing you that this is a curve, but the deformations are so small that you can consider this as one straight line, right? So let's say I am considering this as a straight line, my dear friend. Now this AB I am considering as a straight line. I am showing in this way. And in reality, it is very small. The deformations are very small. What is this? This is gamma. This is gamma. Now, my dear friends, see one triangle is forming over here. One triangle is forming over here. And this curve is so small that you can approximate this with a straight line. You can approximate this with a straight line. Okay. This is the center. This is the center, and this is what? This is the radius. This is the radius. So AB, this is the AB. AB. So can I say AB is r theta? AB is r theta. From your basic concepts, AB is r theta. Okay. What is this? This is the across the length that I have tried to show you. This is the length. This is the length. So this is what? This is the length. This is the length. Okay. So I hope now we are in this triangle. We are in this triangle. What is AB? This part. Earlier we have in this part. This I have enlarged. This has become AB. What is AB? AB is equal to r theta. I have written. This is gamma, and we are trying to analyze this part. I hope now the triangle is clear to you. Okay. Can you say what is tan gamma? Perpendicular by base. So this is r theta by L. And generally it is very small. Theta, gamma is very small. Shear strain is very small. This is very small. This is very small. And if this is very small, so tan gamma will be approximated to gamma. And if gamma is equal to r theta by L. And my dear friends, few slides back I have told you that theta by L is generally treated is constant only. Theta by L is constant only, I have told you. Theta by L is constant. So my dear friends, theta by L is constant. Theta by L is constant. So can I say that gamma is a function of radius? Can I say gamma is a function of radius? And what does this mean? This means that shear strain is a directly, relationship is what? Directly proportional. Straight line, linear variation, straight line, linear variation. This is the variation that has been represented. This is what? This is the case of linear variation. Linear variation. Linear variation. So till now we have just developed the equation for shear strain, my dear friends. And see, from deformation, few minutes back we were talking about deformation, and now we are into the shear strain. That means strain is generated. Strain is generated. This thing you people are able to understand? This thing you people are able to understand? So two angles are there, theta and gamma. Theta and gamma. Theta is not changing with radius, theta is changing with distance. Theta at the, what is the theta value at the fixed end? 0. As you move along, theta is increasing, and at the free end it is maximum. Gamma is changing not with length, gamma is changing with radius. Gamma is changing with radius as per this relationship I have showed you. So gamma is equal to r theta by L. Gamma is equal to r theta by L. Gamma is equal to r theta by L. See, at any r we are analyzing the concept. At any r. Now don't think that sir r is always the capital R and we are discussing at the ekdam extreme end. No, at any general r we are discussing. At any general r we are discussing. So don't get it wrong. At any is a function of radius. Radius is changing. Gamma is also changing. Is it clear? Acha, radius can be anything na. From center you can discuss till over here. You can discuss till over here, or you can discuss at the free end also. So with radius theta is changing. With theta, with origin, radius can keep on changing. Okay. Now, my dear friends, one assumption we have discussed, that loading is within elastic limit. Loading is within elastic limit. And if loading is within elastic limit, you can apply Hooke's law, na? You can apply Hooke's law. So shear stress is equal to strain into G, that is the modulus of rigidity into gamma. What is tau? Tau is equal to shear stress. Gamma shear strain already know, and G is what? Rigidity modulus. Rigidity modulus. So my dear friends, if I have to just analyze this, so gamma is what? Gamma is r theta by L into G, and theta by L is what? It is constant. What is G? G is constant. So can I say that tau is also proportional to radius? Can I say tau is proportional to radius? And what does this mean? This means that linear variation was being shown in strain, shear strain, and linear variation is being shown with respect to shear stress also. And this is all we are analyzing on this cross section. Now no matter how much fancy words I tell you, cross section, this, that, it won't be clear until unless I show you. I'll show you, and I'll show you definitely. But as of now, you understand that this variation is on the cross section. On the cross section. As of now, you are seeing the relations. Okay. So tau by r is equal to G theta by L. Can I say that, okay, we have got one relation? Can I say that we have got one relation? And can I name this equation as 1? Can I name this equation as 1? Tau by r equal to G theta by L. Okay. Now I have told you that, okay, this is there on the cross section. On the cross section, what is the meaning of it? What is the meaning of it? See, this is the cross section that we are talking about. This is the cross section. This is the cross section. When you cut a shaft, at any middle from the this end, I hope you are able to see this thing. You can see na, circular cross section. So on the cross section only you are applying the torsion na. Where you are applying how you are applying the torsion, you are applying in this way. You are applying in this way. So if you are applying in this way, so stress will be generated where? On the cross section. So that is why at the center, what is the shear stress? 0. So that is why it is 0. And as you move along towards the periphery, towards the outer radius, the shear strain also increases, the shear stress also increases. I hope you are able to get this point. Maximum kahan hoga? Maximum it will be at the outer radius, where it will be maximum outer radius, right? So I hope that this thing you people are able to understand. And what this point has written, point is written that the shear strain at points on the cross section increases linearly with rho, and rho is what? Rho is nothing but radius. In this picture it is radius. In this picture it is radius. So I hope that after shouting this much, you people are able to at least visualize that, okay, how things are working out in torsion, and how we are able to generate one relation. So now I hope now this relation is clear, this picture is clear, at least this picture is okay. Now my dear friends, see, this is a very important statement, that external torque leads to internal torque within the shaft. Very strong statement this is. I have applied externally torque, externally I have applied the torque, yes or no? And if I have applied the torque externally, internal torque also gets generated. Internal torque also gets generated. So it is our duty to calculate its value. It is our duty to calculate its value. So all these images are fine, but as of now, let's focus on how to get that torque value. That torque value is very important. So how to get that torque value, this will be our discussion as of now. How to get that torque value, okay. So let us discuss. Okay. So this is the cross section of the shaft, my dear friends. I hope you are able to get. This is the cross section. Okay, let me draw it over here again. This is the cross section that we are discussing. And this will be the center. This will be the center. This will be the center, and in that I am taking one element, circular element only I have to take, na. I am taking a circular element, and in that I will be analyzing the torque. Now at least you can at least visualize and tell me that, okay sir, you have drawn the cross section. You have drawn the cross section, and this element I am trying to analyze. 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 It is at a distance of r, and it is subjected to shear stress. It is subjected to shear stress, that is tau. So consider the elemental area dA. Consider elemental area, that is the dA. Acha, the thickness of it will be dr. The thickness of it will be dr. So if I ask you what is the area, what is the area of this element, you will say that, sir, it is circumference 2 pi r into, that is the length into breadth, so 2 pi r dr. Length into width is the length into width is the area. Okay. So what will be force on this? See, shear stress leads to shear force. So what will be shear force? It will be tau into the area. It acts on area, so tau into dA. And what is tau? Tau is, what relation did we develop? We have to check once again. G theta by L into r. So G theta by L into r at a distance r, df. df is tau into dA. So tau G theta by L into r, and dA is what? 2 pi r dr. 2 pi r dr. So my dear friends, what will be dt? That is the elemental torque. Elemental torque will be df into r. df into r. So df is what? You know, g theta by L 2 pi r square into dr. G theta by L 2 pi r square into dr into r. So let me say I am writing r at the beginning. So net torque, how much? What will be the net torque? So tell me one thing, this is the elemental torque. So net torque, if I ask you, there are so many distances, there are so many elemental strips, na? So net torque, if I ask you, that will be dt. And if dt is there, so I can write that, okay, g theta by L, you know, 2 pi r square dr, you know, r is also there, and I can do some manipulation that, okay, g theta by L are anyway constant, so integration of, you know, r square I can write over here, and I can just write 2 pi r dr, 2 pi r dr I can write. So I can write g theta by L and integration of r square and 2 pi r dr. Just now I have written that, okay, this is the elemental area dA. This is the elemental area dA. This is the elemental area dA. I hope you are able to understand this. R square dA, r square dA. And this term r square by dA, this term integral r square dA is nothing but j, and so that finally it is g theta j by L, g theta j by L. And what is j? What is j? J is the polar moment of inertia. J is the polar moment of inertia. So what is J? J is the polar moment of inertia. So what we were deriving? We were deriving net internal torque, or you can say resisting torque. Somewhere you will be seeing resisting torque also. So net internal torque, that is the T, and that is equal to, what was the relation? G theta by L into J. J is the polar moment of inertia. What is polar moment of inertia? It represents the resistance against torsion. If I tell you what is the significance of moment of inertia, so you will say that, okay sir, it is the resistance against bending moment. If I ask you what is the significance of polar moment of inertia, that means you will say that, sir, it is the resistance for torsion. What is inertia? Linear, simple inertia, resistance against movement or motion, resistance against motion. So inertia represents, the significance of inertia is resistance against some motion. Okay, over here what is the significance? Resistance against torsion. So I can say that T by J is equal to g theta by L. And my dear friends, this is your equation number 2. So equation number 1, if you remember, equation number 1 I have already discussed, tau by r. This is, so combining equations 1 and 2, combining equations 1 and 2. So what do you know? Tau by r is equal to T by J is equal to g theta by L. My dear friends, this is the it's gone. This is the torsion equation, or generally it is called torsion formula. It is called the torsion formula. Torsion formula. So what is tau? Now see, my dear friends, am I talking about the radius r? No, in general any r it is. R is your radial distance. R is your radial distance. Ideally I should have written it small r, so that okay, you can just put the value of that. Okay, at any radius it is giving me the shear stress value, but okay, from the initial I am considering r, so it is the maximum radius I can consider it to be, let's say, some r max, something like this. So let's do only that at the free end, r is equal to r max, so tau is equal to tau max. So accordingly you can substitute in the equation and get the answer. What is T? T is the net internal torque at the cross section, which I have already showed you. J is the polar moment of inertia, which represents the resistance against torsion. G is the rigidity modulus, theta is the twist angle, L is the length of the shaft. So this relation is the the fundamental, or the introduction, the beginning to your torsion. From here you will be having, then once you understand this, once you get this, that how it is coming, what are the terms, once you analyze the figure, all these things, if it is clear to you, then you will just the things will be very easy for you when you go further into the chapter. Many things are there. For example, if I consider that okay, this is the shaft that I am drawing. This is the shaft that I am drawing, and you will tell me that, sir, at the cross section I am applying torque. So do you tell me that, sir, at the cross section the material is subjected to pure shear? Can I say like this? Yes, it is subjected to pure shear. And suppose if I try to visualize one element, see, generally it is in the stressed condition. So I am trying to analyze one element over here. This element, when I bring it over here, that is the outside world, when I show this element the outside world, then it will be something like this. And let's say this is the 3D image of the element. This is small element, when I bring it to the outside world, then it is in this way, this element. Let's do some designing. And this face, which face? This face. This face is subjected to pure shear. This face is subjected to pure shear. So if you ask me what will be the Mohr circle, so many things they can ask you, that what will be the Mohr circle. So Mohr circle will be something like this, where the extremes are the maximum tau. This is one question. Achha, one more thing which I want to discuss with you, the failure. So where on the face, on the let's say the plane ABCD, on this plane ABCD, pure shear is there, yes or no? Yes, sir. On the the cross section face, it is subjected to pure shear. That means material is subjected to pure shear. Material is subjected to pure shear at the cross section. This is at the cross section. Can I say at 45 degree on the plane, at some 45 degree, the plane whatever is there, there it will be having tensile stress also, and the value of that tensile stress is nothing but the value of the shear stress tau. Yes, definitely from our from our stress transformation concept we know that okay, it is there. So that means the cross section is subjected to pure shear, and at 45 degree there is tensile stress. So can I say that tensile stress is maximum at 45 degree? Can I say that the tensile stress is surface पे तो नहीं है, surface पे तो it is 0, where it is present is 45 degree and it is maximum over there. So my dear friends, based on this information, if I ask you what is the condition of, how does brittle material fails and how does tensile material fails? Sorry, not tensile, ductile material, ductile material fails. So brittle material is weak in tension, and where is tension maximum? At 45 degree. That is why when you twist, and this is all we are studying the effect of torque. It is all getting, all the diagrams are getting generated because of torque, torsion. So that is why when you apply torque on a brittle material, for example chalk, it will fail. How? At 45 degree. So sometimes, if you have a chalk with you, try twisting it, try applying torque on it, and you will see that it is failing at, how it will fail? Something like this, that is at 45 degree, I know the diagrams are a bit clumsy, so try to bear with me, but I hope you get the point. And how does ductile material fails? The ductile material fails at the cross section. Why? Because at the cross section shear is maximum and ductile materials are weak in shear. So how does ductile material fails? Exactly at the cross section. That means something like this they will fail. Exactly at the cross section they will fail. So that means ductile material fails at the cross section. And how does brittle material fails? 45 degree. Why 45 degree? But tensile is there and brittle are weak in tensile. Brittle is weak in tensile. So at 45 degree. To the cross section. So this thing I wanted to discuss with you, and basically these are the same images that okay, at the cross section the variation of shear stress he is showing. All those things I have already discussed with you, right? And these are some of the important observations that okay, shear strain is a function of radius, okay, shear strain is a independent of length, all these things, whatever conclusions are there, all these things I have very explained to you, and I have just given in the point format, right? Shear stress is directly proportional to radius, all those things I have discussed. Okay. So my dear friends, I hope that I am able to explain you the concept or the fundamentals of torsion, and I am sure that if you watch this around 1 hour length of video, you will be developing a very sound concepts as far as your torsion is concerned. You will not forget easily because I have helped the visual representations to put the concept in your mind. That being said, if any doubt is there, what is your overall feedback in the entire foundation series? What is your general feedback? You can any kind of feedback, critical or whatever kind of feedback is there, you can very well put in the comment box, and if any doubt is also there, you can put in the comment box, and if I get to see, I will be replying it myself, right? So what is the objective? The objective is that through these sessions, through the 10 sessions that I have taken, my dear friends, your foundation in SOM, that is the strength of materials, have developed to some good point, and you have benefited from these sessions. And if only you benefit from these sessions, then I will ask you to suggest it to your friends in case they are preparing this strength of material subject, whether from the GATE perspective or whether from the semester's examination perspective. It will be helpful to you. And in case you want me to bring such more series, because this is the last video of the foundation series that I am talking about, and if you want me to bring some more series of any subject, then you can drop your chat, drop your comment in the chat box, right? So today is the final day of the series, and I hope that you have greatly benefited from it. This is the Telegram group. You can consider it joining. You will be getting the you will be getting schedule of free white YouTube lectures, then you will be getting the lecture PDFs, then you will be getting important updates related to seminar, webinar, PSU, other government job notifications, expert sessions on many topics, daily quizzes, and much more you will be getting. And if you consider joining, if you want to join the live online program, my dear friends, then you must know the features. This is the features: 800 plus hours of classes, theory book, exercise books and everything, one-to-one sessions and 130 online test. And don't forget the game changer, that is the GQP, a huge GQP you will be getting, right? So with this I'll be concluding the series this March month, 10 lectures on foundation series, and I hope that you go through it, understand it. In case of any problem, just drop a comment section or you join the Telegram group, whatever you can communicate with me, no issues with that, right? So study well. Similarly, many teachers will come on different subjects. They will be taking the sessions and you will be enjoying like anything. So stay connected, keep checking the YouTube channels for further the classes, the courses, and this way in different months, different series will be bringing. This was the foundation. Maybe next month or next to next month some question solving sessions will be there, right? That's it. Keep studying. Take care. God bless.